All right, let's continue. Number 3. 3 to the power of 2x minus 1 equals 2 to the power of 2 minus x. The base on the left is 3, base on the right is 2. Not elementary. We're going to approach this or solve this exponential equation using the approach that we applied earlier for previous 2 examples. So this way, this exponential equation has base 3 on the left and base 2 on the right. Then what kind of logarithm you're going to apply? You want to apply common logarithm or natural logarithm? It really doesn't matter. In this case, it doesn't matter. Either way would be okay. In my notes, I applied the natural logarithm. So here, in the video, I'm going to apply common logarithm. Then you would see, you would end up with the same result. I apply common logarithm on both sides. On the left, by the power rule, again, let me write the power rule here. LOG with base b x to the power of r. We could move r in front to multiply by LOG with base b of x. We move 2x minus 1 in front. Put a parenthesis to frame it. And then multiply by LOG of 3. You move the 2x minus 1 away. Of course, you have nothing on the shoulder of 3 anymore. Same thing on the right-hand side. By the power rule, we move 2 minus x in front. Use a parenthesis to frame it. And then multiply by LOG of 2. Okay? Remember, LOG of 3 and LOG of 2, they are just the numbers. If I switch the order, you might see it better. This is a number. The number times 2x minus 1. And LOG of 2 is a number. Number times 2 minus x. LOG, common logarithm of 3 here actually is the coefficient of this parenthesis. Common logarithm of 2 is the coefficient of this parenthesis. Let's distribute. Because we are solving for x, we would have to get rid of the parentheses and then collect like terms and then combine like terms. Let's do that. Log of 3 times 2x, we have 2 log of 3 times x. Log of 3 times negative 1, that is a negative log of 3. On the right, we have log of 2 times 2, that is 2 log of 2. Log of 2 times negative x, that is a negative log of 2 x. So you see 1, 2, 3, 4 terms. This term and this term, they have x. Those two terms have no x. Collect like terms. I keep 2 log 3x here and then move this term over plus log 2x. We talk about the transposition of terms, right? You can move those terms around. All you need to do is to, whenever you move a term from one side to the other side, you move it and then you change the sign. You move it over, negative becomes positive. And on the right-hand side, you have 2 log 2. I just copy this term. Nothing has changed. And I want this term on the right-hand side. So I move it over. Negative is gonna become positive. Positive log 3. Like terms are collected. Let's combine like terms. Combine their coefficients. That is 2 log 3 plus log 2. Inside the parentheses times x. On the right, we have 2 log 2 plus log 3. One more step to isolate x. Divide both sides by the coefficient of x, which is 2 log 3 plus log 2. 2 log 3 plus log 2. And they cancel out. X is isolated. Coefficient of x becomes 1. X equals, on the right, we have 2 log 2 plus log 3 over, all over, 2 log 3 plus log 2. If you apply the calculator, you would see the same result. You would see the same result. By the way, maybe this looks kind of complicated to you. Then we actually could do something to compress. We could do something by using the properties of logarithms to compress this expression. Because all those 4 logarithms have the same base, 10. Here we can put 2 back inside the anti. We would have log 2 square, and here is log 3. Same thing, we put the coefficient 2 back inside the anti. We have log 3 square plus log 2. Those are extra. You could actually evaluate this expression to get an approximation of the answer. But if you want to play with it, we can compress the exact answer as simple as possible. So now we have log 4 plus log 3 on the top. We have log 9 plus log 2 on the bottom. By the product rule, numerator, we add those 2 basis logarithms together. We have a common logarithm of 12. Yes, you're going to multiply 4 and 3 together. 4 times 3 equals 12. Same thing on the bottom. Add them up. We have a common logarithm of 18. Okay? And then you use your calculator. You would have the same decimal approximation with the answer in my notes. That's number 3. Let's move to number 4. Number 4 is a logarithmic equation. We have a logarithm with base 2 of x plus 3 plus log with base 2 of x plus 4 equals log with base 2 of 3x plus 8. Number 4, we are solving a logarithmic equation. I recommend you take time to really understand, make sense of these problems. This problem, very important. This is a very good example. All right, I see 3 basis logarithms, 2 on the left, 1 on the right, and nothing else, no other terms. So I would maybe compress the left-hand side because it's so convenient, right? You see the addition of 2 logarithms with base 2. If we apply the product rule, we would have logarithm with base 2, and then you're going to multiply the 2 antis together, x plus 3 times x plus 4. You multiply them together, and equals logarithm with base 2 of 3x plus 8. All right? And what else? So now you have one single logarithm on the left, you have one single logarithm on the right, and they have the same base. Shouldn't they have the same anti as well? Corresponding part equal to each other. We saw something like this before, right? The 2 log equal to each other. Base are identical, are the same. Then their corresponding anti-logarithms supposed to be equal to each other as well. So we would have x plus 3 times x plus 4 equals 3x plus 8. Now we are looking at a simple quadratic equation. Let's FOIL here. Let's take time to FOIL. because I don't worry about the first 10 minutes. So let's take time. First times outside, outside, inside, inside, last, equals 3x plus 8. First, xx, outside, outside, x4, inside, 3x, last, 3, 4. And then we organize, multiply the terms. X times x is x squared, it's not 2x, okay? X times x is x squared. 4 times x, 4x. 3 times x, 3x. 3 times 4, 12, equals 3x plus 8. Just for convenience, I can get rid of 3x from both sides. And then I have x squared plus 4x plus 12. I move 8 over, minus 8 equals 0. Combine like terms. 12 minus 8, 4. The quadratic equation now is in a standard form. Let's factor it. It's easy to fact. It's easy to factor. It's easy to factor. Find the two numbers, multiply to 4, add up to 4. You know that's 2 and 2, right? So you have x plus 2 times x plus 2 equals 0. So the left-hand side actually is a perfect square trinomial. Perfect square trinomial. The left-hand side is the square of x plus 2. Then we would have x plus 2 equals 0. Of course, if a perfect square equals 0, the base is 0. That gives us x equals -2. Are we done? Not yet. Very important thing about solving a logarithm equation is you have to check your result. It is mandatory, not optional. You have to check your result. You have to check your result. So how do you check your result? You plug in back. Let me copy the original equation. Let me change the color. log base 2 x plus 3 plus log base 2 x plus 4 equals log with base 2 3x plus 8. Let's plug in x equals -2. We have log with base 2 of -2 plus 3. And here we plug in the anti is -2 plus 4. On the right hand side we plug in, we have 3 times -2 plus 8. -2 plus 3 is 1. log with base 2 1. -2 plus 4 is 2. 3 times -2, -6. -6 plus 8, 2. Did we talk about this before? I think in previous video. If we have a logarithm, the base and anti are identical, then the logarithm equals 1. So same here, 1. And if we have a logarithm, doesn't matter the base equal to what. As long as the anti equals 1, the log equals 0. So we have a 0 here. So this logarithm is 0. 0 plus 1 equals 1. We got a true statement. Means -2, this proposed solution is an actual solution. You can make a conclusion. Thus, the solution set of the original equation is a set containing one solution only, which is this, -2. Sometimes you would find out the proposed solution doesn't really satisfy the original equation. Then you would have to get rid of it. I think we might see that later. In this case, this is number 4, right? In this case, we got one proposed solution, and after we check it, we know the solution is the actual solution, so we keep it. But sometimes you would see the proposed solution is not the actual solution, it's extraneous. Then you would have to eliminate it. Let's see the next one, number 5. Number 5 is also a logarithmic equation, log with base 7 of 4x minus log with base 7 of 6 equals 2. In this equation, we see two logarithms, and we also have a constant term on the right-hand side. So very natural, you want to combine, or you want to compress the left-hand side, right? This is a subtraction or difference of two like basis logarithms. Do you remember quotient rule? Yes, quotient rule. We are able to rewrite the subtraction as one single log with base 7. The anti is going to be the quotient of the original two anti. Be very careful with the order. 4x go on the top, 6 go on the bottom. 4x over 6. Yeah, we know we could reduce 4x over 6, that is 2x over 3. And how do we continue from here? This equation is a simple logarithmic equation, or this equation now is in the logarithmic form. So could we maybe try to convert this equation to its equivalent exponential form? In the beginning of the previous video, I did that. I give you the formula. So we're going to convert to exponential form. Take the base 7 to the power of log 2 equals anti 2x over 3. What is the 7 square? 49. 2 over 3 times x. How do we get rid of the coefficient of x? Let me switch the both sides, because sometimes we feel better. By convention, we get used to have the unknown variable on the left-hand side. So one more step to get a value for x. We need to get rid of the coefficient. Coefficient of x is 2 over 3. We are going to multiply both sides by the reciprocal of 2 over 3, which is 3 over 2. They cancel out, right? 2 over 3 times 3 over 2 equals 1. Then we have x isolated on the left-hand side. Right-hand side, 3 over 2 times 49. What is 3 over 2 times 49? We're going to keep the fraction. We would have 49 times 3. 147 over 2. Or if you want, you can rewrite it as a decimal. That would give us 73.5. Either way is fine, okay? You can write the answer as a fraction, but the fraction needs to be reduced. Are we done? Not yet. What do we need to do here? We need to check, right? Yeah, we need to check our proposed solution. Even after we check, we keep the solution. It's not a waste of time, because you wouldn't know should you keep it or eliminate it, right? You do have to check the result to get to know that, to make the decision on that. Original equation log 7 of 4x minus log 7 of 6 equals 2. Let's plug in the fraction. This might be better. So we plug in log with base 7, 4 times x, so 4 over 1 times 147 over 2 minus log with base 7 of 6 equals 2. Log with base 7. 4 and 2 cancel out the GCF 2, then we have 2 on the top. 147 times 2 gives us 294, right? 294 minus log with base 7 of 6 equals 2. Condense, keep the base, take the quotient of 294 over 6. We are applying quotient rule, equals 2. Divide 294 by 6. You have a calculator, so you can do that very fast. You would have 49. Log 7 of 49 equals 2. convert that equation to equivalent exponential form, 7 to the power of 2 equals 49, and that is a true statement. Means the proposed solution, this guy, 147 over 2, satisfies the original equation. It is an actual solution. So we can make a conclusion here. Thus, the solution set of the original equation. I would skip writing those words. I'll just say it. Thus, the solution set of the original equation is a set containing one solution only. The one solution is 147 over 2, or 37, or 73.5. So far so good? Number 6. Number 6 is also a logarithmic equation. Let me copy the problem. Base is 5 this time. Anti-x minus 1 plus logarithm with base 5 of x plus 4 equals log with base 5 of x minus 5. Let me double check. So you see 3 like bases, logarithms in this equation, x minus 1 plus 4 minus 5. Okay. So how do we solve this equation? We have seen a very similar one earlier. Kind of like so do you think we can stop here and start part 3? Because it's already 20 minutes. So we will talk about number 6 in the next video, okay?